Okay. So
Okay.
I hope my screen is visible.
Mm-hmm.
Okay. So today, before we start, although let's go with the networking first. Okay. So what is networking? Even though we had some discussions on our last session as well. Okay. One moment. Okay, so what is network? Okay, so network is the same way, like suppose we have different cities. Okay, you have New York, then Texas. Okay, then we have Florida. Okay, so although like Washington DC and Illinois. Okay, so like there are multiple cities. Okay, those are connected to each other. Okay, so if you want to go from one place to another place, okay, so either we are connected with the highways, roads, or by train routes or flights. Correct. So we follow
Yeah.
a path. Okay. So let's suppose we only have roads or highways. So how you will go? Okay. So first you will come to the New York, then Texas, then Illinois. Okay. And if you want to go to Florida, then you have to come there. Correct.
Mm-hmm.
So they are interconnected, okay, and making a network. So how you will go? Let's suppose you want to go from DC to Florida, okay. So here, you know, to go to the Florida first, we have to go to the New York, okay. So you will be directed to this way. So now might be on New York, you will be having multiple roads connected, correct? But here there will be some signing boards, or you will ask to the people, hey, I want to go to the Florida. So they will direct you. First, you have to go to the Texas, and then in the Texas, you will be having multiple cities connected or multiple highways. Then here, what you will do, you will ask people, or you will be having the signing boards. Okay, those will be directing, hey, to go to the Florida, please take right. Okay, and
Yeah.
then you will reach
Yep.
Florida. So they are connected to each other, but without the signing board and without asking to any people, will you ever be able to reach to Florida? Nope, because you are
No.
not asking to any people and there are no signing boards. You don't know like which way I need to go to reach here, correct? So
Correct.
the routing, the people or these signing boards or people whom you are asking, they plays very important role to take you to your destination, correct?
Mm-hmm.
So the people or signing boards, those we have, these are the routers. Okay, those are telling us route how to reach to Florida, correct?
Correct.
And here we are using the name cities, okay? DC, New York, Texas, Florida, Illinois, okay? So these are the
Mm-hmm.
naming convention, okay? Those are easy for the human beings to remember, okay? That's why we are keeping these things. But when it comes to the network, okay? So in the networking, what we have routers, okay? The devices that we have. There are multiple routers, those are connected. Okay, and the addressing scheme that we use on the routers is the IP address. Okay, so let's suppose, so here we are not using any city name, so we are using, let's suppose the IP address is 7.7.7.7. Okay, and here let's suppose your PC IP address that you got is 1.1.1.1. So now your source is this and your destination is 7.7.7.7. It means you want to forward something to this particular PC, correct?
Mm-hmm.
So here we will be having multiple routers. So these routers, they will be having their another IPs. Let's suppose 1.1.1.2. Here it has 3.3.3.1, 3.3.3.2. This is 4.4.4.1. This is 4.4.4.2. This is 5.5.5. Although like this will be a different IP, okay, but I'm using simple IPs, okay, just to make you understand.
Mm-hmm.
5.2, okay, then 7.7.7.1, okay. So this is how first your packet, okay, you will forward your packet to this router, okay, that is directly connected to you, okay. So what will happen on this router? It will check, it maintains the routing table, okay. The signing boards or the people who were telling us in real life, here they have the routing table, okay. Routing table. So these routing table, they maintains the next hop. So let's suppose you want to go to 7.7.7, okay? So here it will tell you, hey, the next hop is 3.3.3.2, correct? So
Correct.
if you want to go there, so first you have to, like your packet will reach here, here it will tell you need to go to this, correct?
Yeah.
Now, this router, it will maintain its own routing table, correct?
Correct.
Here, it will tell, okay, if you want to go to 7.7.7.7, so please go to 4.4.4.2, okay? Then your packet will reach here. Then this router will have its own routing table, correct?
Correct.
Then your packet will come here, then it will have its own routing table, and it will tell, okay, please go there, and then your packet will reach here, okay. So these devices, those are telling us the route, we call them router in networking, okay. So there are so many routers, those are, the ISP, the internet provider, AT&T, Verizon, Sprint, okay, they manage this, okay. So
Yeah.
they keeps track of everything. It just, you will get your public IP address, okay, and your server, whatever you want to reach. So your packet will reach over there. Okay, this is how the packet travels over the internet. Are you able to relate it? Just relate it with the real world. Okay, they took the
Real world.
scenario
Yeah.
from there and they plotted in the name of devices. Okay. Now, what are these IP addresses? Okay, what is the range of these IP address? First, we need to understand that. Okay, so there are, let's go there first. So we have, protocols, okay, IPv4 and IPv6. Although IPv6 is not being used so far, okay, so we will only discuss about the IPv4. So these are the range of IPv4 header. Okay, sorry, IPv4 IP ranges. Okay, so what is the first class? Class A. It's IP address. Okay, so they are in 4 octets. Okay, so we have 4 octets, okay? 1, 2, 3, 4. And why we call them octet? Because it's a 32 bit address. Okay. So 32 bit means, okay. So let me, so you are not aware about bits and bytes, correct? Okay. So 8 bit equals to 1 byte. Okay.
Yes.
Okay, 8 bit equals to 1 byte. Now you have 4 octets, okay, 0.0000000. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay,
It's
so this
that's
is
one byte.
1 octet. Then you have another octet, means 8 bytes that you have. Then you have another octet. So this way we have 4 octets for the IP headers. Okay, that is why we call it IPv4. Okay, so we have
Okay.
4 octets. So if you consider what is the minimum value that we can have, if you will see 0, 0, so these are the bits, okay, binary 0, 0, 0, 0, 0, 0, 0, 0. Okay, so the minimum value can be 0, correct?
Yeah.
And if you will make all of them 1, 1, 1, 1, 1, 1, 1. So in binary, we only have 2 digits, either 0 or 1, correct? So if it is 1, so how they are being calculated? So they are being calculated 1, 2, 4, 8, 16, 32, 64, and 128, correct? So how many we have? 1, 2, 3, 4, 5, 6, 7, 8, correct?
Correct.
So if we come here and let me just show you. So the minimum value 0, 0, 0, 0, 0, 0, 0, 0. it is equals to 0 and 1 1 1 1 1 1 1 1 equals to, okay, so if you will add all of them, okay, it will be equals to 255, okay, because we need to add 1 plus 2 3, 3 plus 4 7,
7,
7 plus 15, 16 plus,
15,
okay,
19,
31, 16 plus 15 equals to 31, 31 plus 32 like your 63, okay,
63,
and 64 plus 63 equals to 127, and
127.
127 plus 128,
Yes,
255.
that's 255.
Okay, so
Yeah.
if you will add all of them, it will be 255. But what will be the value of this? 0 0 0 0 and 0 0 0 1? What will the value of this? One moment, let me just close this, come there. Okay, now you see it.
Okay.
Okay, so now here we are counting it 1 2 4
Wow.
8
It's
16
16,
32
32,
64 and 128. So
128.
here all of them are 0, but this one is 1. So if it is 1, it means it is equals to 1, correct?
1. Correct.
Now 0 0 0 0, and then you have 1 0 0 1. So now you see 1, whatever equals to 1, we will count them.
It's
Okay, 8 or 1. What is? It is 9.
9.
Okay. So same way, if we make it 0 1 0 0 0 0 0 0. So this one is 64, correct?
64.
So it is equals
Correct.
to 64. Understood?
Uh-huh.
And if we make all of them equals to, it will be equals to 255. Okay. So
That's fine.
our maximum range of one octet can start from 0 and can go up to 255, correct?
Uh-huh.
So same, this is 0 to 255. This is 0 to 255, and this is
55.
0 to 255, correct? This is minimum
Correct.
and this is maximum, correct?
Uh-huh.
And in between, we can use any range. Okay, so any range means so 0, 1, 2, 3, 4, 5, 6, and so on up to 255, correct?
Uh-huh. Uh-huh.
So this is the range of our all the octets. Okay, each octet's range can be 0 to 255, 0 to 255, 0 to 255, 0 to 255. Understood?
Understood.
Okay, now the same thing, if we will go back to this, so here they have divided these ranges into 5 classes. Okay, so we have
Uh-huh.
5 classes here. So class A, its IP address range is from 0 to 127. Okay, so if you have an IP address, okay, that starts from either 0 or like let's suppose it is 0.1.1.1. Okay, so although 0 class is reserved by IANA, okay, it is not being assigned to anyone. So the IP address range that we use, we use it with the 1.1.1. Okay, so if the IP, your IP starts, so here you see your first IP, okay, your first octet. If first octet value is from 0 to 127, it means it
Uh-huh.
is class A address. Okay, the rest can be anything. It could be 127. Sorry, let's suppose we take only one IP. Okay, let's suppose 2. So 2 comes under 0 to 127, correct?
Uh-huh.
So if it is 2.1.1.10, so just look at the first IP. Okay,
Uh-huh.
it is 2. In which range it comes? 0 to 127. 0 to 127, it is a
Uh-huh.
class A address, correct?
Yes.
Now, class B range is 128 to 191. So let's suppose your IP address is 131.3.4.7. So which
Uh-huh.
class address is this?
That is class B.
Yes, that is class B because class B range is 128. So it could be
128.
one, it can be start from 128, 129, 130, and it may
Yeah.
go up to 191. Okay.
Mm-hmm.
So now the rest of IPs could be anything. So if your first octet, first IP comes under this range, it will be class B. Then we have class C. Okay. So your class C range is 192. If the IP starts from 192 to 223, it means it's a class 3. Let me give you 200.3.200.5. Which class IP is this?
That's class C.
Yes, class C. And same goes for the class D and class E, but class D is not being used for the norm. We don't assign these IPs to the devices. Why? Because it is only for the multicasting. Okay. We cannot assign this range IP address to any of these devices. Okay. Even your router,
Mm-hmm.
your PC, your laptop, your firewall, no device can have the IP address from this range. Okay.
Okay.
Because it is
Mm-hmm.
reserved for multicasting, correct? Now the
Yes.
last class that we have, this is class E. This range is completely reserved and not for the users, okay? Even you cannot use this for the multicast. It is for experimental purpose. Might be they will use in future or they may not, okay? This is reserved. So the only IP addresses that you can assign is from 0 to 224, correct? So
Mm-hmm.
0 to 127 class A and 128 to 191 class B and
Mm-hmm.
192 to 223 is the class C, correct?
C. Yes.
So you understood what is classes in the addressing scheme?
Yes.
Now, how many addresses that we can have in class A? So here there is another term that we use, network ID or host ID. Okay. So what
Mm-hmm.
is network ID? So because our IP address, they are in the range 1.1.1.1, correct? Which
Yeah.
class address is this?
Class A.
Class A. Okay. So here we use the subnets. Okay. So if it is for class A, so here we will be using, because see, we have 4 octets. Okay. 0.0.0.0. Okay. So they are 8 bits. Okay. 8 bit, 8 bit, 8 bit, and 8 bit. Correct.
Mm-hmm.
And completely they are 32 bit. Correct.
Yes.
So class A. So only network portion of the class A is 8 bit. Correct. So we use
Yes.
slash notation. Okay. Slash 8.
Mm-hmm.
Slash 8 means the first octet will be freeze. Okay. It will not change. Okay. So let's suppose you are working in any company. Okay. And your company bought an address and, like internet authority, they give you an IP address for 1.0.0.0 slash 8. Slash 8 means the first octet. If it is slash 16, it means first and second both octet. Correct.
Mm-hmm.
If it is slash 24, it means first, second, and third, and all
Mm-hmm.
3 octets. Okay. They are
Yeah.
freezed. You cannot make any changes, but the last octet you can make. So let's suppose your IP address that you got is 1.0.0 slash 8. It means the first octet is freeze, correct? You cannot change this, but now you have the range of IP address from this, okay? Because this can go from 0 to 55, correct? Then it
Correct.
can also go from this third octet can also go from 0 to 255, correct? And then 4 octet
Mm-hmm.
can also go to 0 to 255, correct?
Oh, correct.
Okay. So if you will see how your IP addresses can be. So let's suppose your first IP 1.1.0.0.1. Okay. So when it will reach to 2, 3, up to 255. Then you just do one thing, 1 dot 0 dot, make it 1, then again start it from 0 to 1, 2, 3, 255. Okay. Then when it reaches, then you again come to 1 dot 0 dot 1, sorry, 2, and again start from 0 to 255. Okay. Then again from 1 to 0, and then 3 dot 0 to 255. Correct? So you will be having so many IP addresses, and when it also reaches 255, then you make the second octet 1, because with just only 0, how many IP addresses that you can assign to the devices, correct?
Yeah.
So it means in class A, if you directly go, like if you get this 1 dot 0 dot 0 dot 0, how many IP address that you can have? 2's to power 24 minus 2. Why we are doing minus 2? Because you cannot use your first address or last address. Because first address is your network address. This address is your network address.
Yes.
And what will be the
Yeah.
maximum address is 1.255, 255, and 255. That will be the maximum address in this range, correct? So this
Correct.
will be your broadcast address. Okay. Broadcast means if you will send anything on this particular packet, so all the IPs in this range, okay, they will get the same packet. Okay.
Right.
Okay. So it's the same thing. Let's suppose you are in your office. Okay. Or let's suppose you are in your college. Okay. And your teacher, he wants to share the details one by one. Okay. So what he will do, he will share, because if it is unique detail for all of them, so he will not say it loudly, correct? He will call you in the
Yeah.
cabin and he will share those, suppose it's your report card and he's sharing it with you. Then again, he will call another person in the cabin and he will share that report to that. Okay. So it is a one-to-one communication that is happening, correct? But what your teacher is giving you an assignment, okay, that is for complete class, okay, just to do assignment of your unit or your chapter 2, correct? And you have to submit it tomorrow. Now this is something that it will be a waste of time if he will call one by one everyone, correct? Because it's the same thing that he's telling to everyone. So what he will do, he will come into the class and he will loudly say, hey, like I have got something for you guys. Okay. You have to complete your unit 2 assignment and submit it by next week or whatever time. Okay. So he is broadcasting. Okay. In one go, he's telling to everyone. He's conveying the same details to everyone. Correct? So the same way, if you have any packet or any traffic that you want to send to everyone, so we will use the broadcast address, the last address of the range. Okay.
Yeah.
So that is why you see host per network ID. That means how many hosts can be in per network. Okay. So first address we cannot use because it will be the network address, correct? And what will
Correct.
be the last address? 1.255, 255, 255.
5 to
That will be
55.
your broadcast address. Okay.
Yeah.
Broadcast address. So these two addresses cannot be assigned. Okay. That is why they are, subtracting that two value. Okay. Now, when it comes to, class B. So in the class B, okay. So here, if you comes to the, bits, okay. So we have 1, 2, 3, 4, 5, 6, 7, okay, and 8. So if it is class 8, your this bit will be 0, okay. It will be unchanged, and these bits can be 0, 0, 0, 0, 0, 0, and can be 1, 1, 1, 1, 1. Okay. So how they can be? So first bit is fixed, then 0, 0, 0, 0, 0, 0, 0. Okay. Okay, 4 and 4. Now your range will start. Okay, so maximum can be up to 1, 1, 1, 1, and 1, 1, 1, and but this will remain 0.
Yeah.
Okay, so range is 1, 2, 4, 8, 16, 32, 64, and 128. Correct?
128, yeah.
So if all of them are 0, that means equals to 0. Correct? And if
Correct.
all of them are 1, but except this, if you will count all of them, they will be
64.
equals to 127. Correct?
1 plus. Oh, okay, minus.
Okay, so if you will add 64 plus 32,
Oh, you're right.
okay, then 16, then
Uh-huh.
8, then
Uh-huh.
4, then 2, then 1, they will be equals to
Yeah.
127. And that is how
7.
the values are being calculated for the class A, 0 to 127. Okay. Now, for class B, when it comes to the bits, how they are calculating? Your minimum can be, 1. So these two are fixed, okay? Because in the class A, only first bit was fixed, correct? And here,
Uh-huh.
these two are fixed, okay? And what could be the minimum? 0, 0, 0, 0. So equals to
Uh-huh.
0, and maximum could be 1, 1, 1, 1, 1, 1, 0, and 1, correct? So this is
Uh-huh.
maximum. So if you will add all of them, let's suppose 1, 2, 4, 8, 16, 32, 64, and 128. Correct?
Mhm.
So
Correct.
if it is 1, oh sorry, I'm sorry, this is 1. So 1 is last is 128. So the minimum address will be 128 for class B. Correct?
Correct.
Because these two bits are fixed and last bit is set 1, it means it will be equals to 128. Correct?
Right. Right.
Maximum will be, this is 0. If you will,
Subtract
add all of
64.
them, it will be
Uh-huh.
equals to 191.
Okay.
Okay? Because this
Right.
is already set 0. So this is how,
0.
if you will go so deep and you understand, okay, how these things are calculated. Okay? So this is how these things are calculated. So same way for class C, what is happening? You have first 3 bits are fixed. Okay? These are fixed. You cannot make any changes. Now this is 4, then 0, 0, 0, and 0. So what is the value of last one? 128 and 64, correct? So
Uh-huh.
what is the minimum value? If you will add 168 to 64, 6 to 8 equals to 2, and 6 to 8 and 1,
192.
9, 192. Okay, so this is the minimum address. And this is how the minimum range of class C starts and where it ends, 2 to 3. So if you will make
Yeah.
all of them 1, 1, 1, 1, and 1, and make them 0, 0. Okay, just subtract this. Okay, 32 will not be considered. And if you, and total, is 255, correct?
Uh-huh.
If from 255, if you will subtract 32, it will be equals to 3, 2, 2. Okay, 2 to 3.
Uh-huh.
Okay, so your range goes to 2 to 3. And this is where it is, 2 to 3.
Uh-huh.
Okay, understood?
Yes.
Okay, and same for class D and class E. Okay. So now you understood how the IPs ranges are for class A, class B, and class C.
How they are structured, yeah.
Oh, okay, great. Now, this is where we have the class full. Okay, these are class full addresses, correct? But
Uh-huh.
let's understand, like if you will assign or if you will calculate 2's to power 27. Okay, let me just open the subnet calculator. Okay. If you just open subnet calculator on the internet, and let me give you an address 1.0.0.0. Okay, and here /8 we are using, correct? For class A. And let me just
Class A,
calculate.
okay.
So see, if you assign this particular IP to any organization, so how many addresses that they can have? Almost 17 millions.
Mm.
So do you believe, do we have any organization that has 17 millions of, users in one
Mm.
company, in any organization? Do they have that number of? No, correct?
No.
So if we will assign that one range to complete range to any company, so it's a waste of resources, correct? Waste of
That's
IP
correct.
addresses because they will not be using all of them. So what
No, there was.
they come up with the new term that is subnetting. Okay. So
Uh-huh.
subnetting means they will not assign complete IP. Okay. But they will assign a range. Okay. Specific
Correct.
range. Okay. So what these ranges are. Okay. So what they did. Okay. So 1.1.1. Or let me just remove this 1.1.0.0.0. Okay, so one user, like one company is coming and they are saying, hey, we need an IP address. Okay, and our requirement is only around 250 users. Okay, they said we only need 250 public IP address. Okay, we don't need much. So what you will do, like we will provide him an IP address 1.0.0.02. Okay, although the range IP addresses that we can assign in the multiple of 1, 2, 4, 8, 32, 64, 128, and 255. Okay, it's not
Uh-huh.
that if they are coming only, "Hey, I need 3 IPs." So we cannot give 3 IPs. Okay, so either you take 2 IP or take 4 IP. Okay,
Uh-huh.
then either you take 8 IP or 32 IP. Either you take
It's right.
64 or 128. Okay, or 255 if you
Uh-huh.
need it only from one range. Okay,
Right.
yeah. So here user is saying I need 250 IP addresses. So in which range it comes? 255, correct?
Uh-huh.
So we will give him 250 IP addresses. But here you see from 0, 1, 2, 3, 4, 5, 6, 7. Okay, it will go up to 255, correct?
All
So
right.
what we can do so that user will only get these IP address. Okay, so he will not be able to use this. Okay, so what we will do, we will fix it. How we are fixing it? The slash notation 1 is equals to 8, 8,
It's
8. Okay, so in the initial, I showed you how we are denoting the IP address for class A with the /8, correct? So the
uh-huh.
uh,
That
first will be
man
the
change.
first octet will be network ID, and these are the host, okay, where the user can change. So what if,
Uh-huh.
because this is denoting our network ID. So what if we make it 24? Okay, what if we make it 24? So if you make it 24, it means 8, 8, 8. The 3 octets, they will be fixed. Okay, they will be unchanged. Correct?
Correct.
So only user can change the octet of last, the IP address of this. Okay. So you will give IP address to the users with subnet mask. We also call it subnet mask. Okay. And subnet mask we define in two notation. One is slash notation. If you are using slash notation, it goes from, like 1, 2, 3, 4 up to 32. Correct?
Uh-huh.
Because we have 32-bit addresses. So if you are making /24, it means the first 3 octets will be fixed. Okay. And the
Uh-huh.
last user can use from 1, 2, 3, 4 up to 255. So it's their IP addresses. So now you
Right.
will assign this particular IP address 1.0.0.0/24. It means the first 3 are fixed. So now these are assigned to the users. Now user can only change this IP. If user will change this, no man, it will not work for him because that is not the internet, the INA authority. So we have an authority, okay, that is Internet Authority of Network Association. Okay. So I believe this is the full form that they have. Let me just check. IANA. Okay, Internet Assigned Number Authority. Okay, INA. So it's an authority that maintains these IP addresses, okay? Whom to assign, whom to not, okay? So if any company, they want public IP addresses, they will go to these authority and they will give the public IP address, okay? Understood?
Yeah.
Okay, great. Now, although like this is the first time, okay, that you are reading, and this is normal human tendency. Whenever we learn something for the first time, we don't understand it completely, okay? So it's normal behavior, just don't worry, okay? But when we use these things multiple times, when we do the repetition, then we start understanding, okay man, this is what it is. So after, a month or two, so what will happen? If I'll tell you IP address, you will tell, okay man, this is the IP address, okay? If I'll tell you subnet mask, you will simply tell, okay, this is the subnet mask, okay?
Yeah.
So just don't consider, hey man, Rishi is, today is telling something that is going over my head. This is normal human tendency that we don't learn 100% in one go. Okay.
You're right.
Yeah. So now, let's see, you got the IP. So what we call it subnetting. Okay. So subnetting, let's understand it in this way. Okay. So there is a land. Okay. It's a very big farmland, and you are going to buy a land for to build your house, okay? Although it is not relevant for you to buy everything, and even you cannot afford completely, okay? What you say, hey, I cannot afford completely, okay, and even that is not my requirement, okay? I want only a small portion, correct? So let's suppose the complete cost of this is like, let's suppose, although I'm just using simple thing, like $1,000, okay? Although it will be in millions and billions, $1,000. But if you divide it, so in $10, so you say, hey, my budget is only $10, okay? So they will give you that part in $10, correct? Oh man. Okay, so they will give you only that part as per the $10, correct? Or $100. Let's suppose, let's divide it into the five. Okay, so this and 10. Okay, $100. Okay, it will be total $1,000, correct?
Uh-huh.
So now you cannot afford complete. Okay, that's why what they did, they divided it into the 10 pieces, and they say, hey, as per your budget, you take this. Okay, because that is what
Uh-huh.
your requirement. So same way, the IP address range that we were using, okay, if we go with this rule /8 means 17 millions, okay, IP address, but those are
Uh,
really not required. It's a waste of, money, or, IP addresses that we have. And let's suppose, and same here. So if you even buy complete, okay, so it's a waste of land, okay? Let's suppose you are not going to use it anyway, okay? Not even for the farming or anyway, okay? So it will be a waste of, a land. So, other people can use it. So that is why they gave you only that part, okay? That is required for you, okay? So now the same thing, when we are doing subnetting, okay, what we are doing, we are only providing the specific IP address, okay, a specific range. So now you can provide, 1.0.1.0/24 to a different organization. You can provide 1.0.2.0/24 to a different organization, correct? So suppose this is provided to organization, X. Okay, suppose this is to Google, this is to, like Facebook, and this they provided to SpaceX. Okay.
uh-huh.
Okay, so that's the benefit of subnetting. You understood why they came up with this solution. Now you can
Go
relate
back.
it, Mamu.
why do they come up with this
Okay.
solution?
Yeah, they come up with this solution. One moment, let me just. So you understood this land scenario. So whatever was
Yes,
your
yes.
budget or
They're
requirement.
going to be too expensive, so they have to
Yes.
share it to
Yeah.
different boxes.
Yes.
Yes.
Yes. So they will provide it. So now, like, 10 people can live or 10 families can live in the same land. Okay. The same
Yeah.
way, the initial IP address that we were providing, okay, /8, it has around 17 millions IP. Okay. Public IP.
Yes. Which
Correct.
is too much.
Yeah, which is too much. So what they said, okay, we will come up with a subnetting. Okay, they call it subnetting. Okay, so in the subnetting, what they are doing, they are doing subnetting 10.0.0.0/24. So now this user will only have 255 IPs, correct? And suppose those IPs are assigned to Google
Correct.
field to Internet Authority, and they say, hey, I need 250 or 255 IPs. So they will give this IP. Okay. So all these three are fixed. Now the Internet Authority, they can use this range to assign IP to different. So let's suppose 10.0.1.0/24. Okay. It will have a different IP range, correct? Because here
Mm-hmm.
the first three, these are different. Here it is 10.0.0 and here it is 10.0.1, correct?
Mm-hmm.
So this is a different range, this is a different range. So let's suppose they assign this to Facebook. Okay. Now
Right.
10.0.2.0/24, they assign it to the space X. Okay. Now
Okay.
10.0.3.0/24, let's suppose they assign it to the some government organization. Okay.
Mm-hmm.
So this is how the 17 million, without subnetting, we have to assign this complete range, correct?
You're
Now
right.
with the subnetting, this slash notation, we were able to fix the IPs. Okay, we were able to have a control over this range. Okay.
Mm-hmm.
So now we can provide these ranges, specific ranges, with the limited number of users. Okay,
Mm-hmm.
whatever customer requirement or users company's requirement, like how many IPs that you need, they provided this. Understood?
Right.
Okay, now this is not a rocket science. Okay, so like you do not need to calculate these things. Let me tell you, just go to Google. Okay, search for subnet calculator. Okay,
Mm-hmm.
uh, subnet calculator. Okay, and then open it, any calculator. Okay, you will find multiple here. So here, as per the requirement, okay, let's suppose you need how many users you need. Okay, so let's suppose okay, by the time you will understand it, so the IP address range is 10.1.0. Okay, and your requirement is let's suppose you want one moment. Okay. Okay, just click on calculate. So here it
No
will
class,
tell
you
you.
didn't choose any class.
Yeah, either you select it or not select it. Okay, that's fine.
Okay.
Because here now
Uh-huh.
we are doing subnetting. Okay.
Right.
So we are using classless. So here you
Okay.
see your range, usable range will be 1.1.1.1 to 1.1.1.254. Okay.
Oh.
Because your first address will be network address. Okay. And your last address will be broadcast address. Correct?
Mm-hmm.
So how many users or you can assign these IPs? 254.
Oh. Oh.
Okay. So this is 254. If you are using /24 notation, let's suppose your requirement is also minimum. So let's go with the like /21. Okay. Just click OK. Now in this /21, let's suppose your requirement is more. So what you will do, you will go with this from this range. I need, my requirement is around 2000 users, correct?
Uh-huh.
So they will give you a /21 notation. Okay. So here your usable IP, your first IP will be, this will be network address, and this will be your broadcast address. Okay. And this will be your usable address. Okay. So usable address means, let me just tell you. So now here you will be having a question, hey, why we have 0 and here we have 1, correct? So here
Right.
your IP range will start from 1.1.0 dot, here it will go from 0 to 255, correct? Then the next will be 1.1.1.0 to 255. Okay. Then it will go, next one is 1.1.2.0 to 255, and it will go up to 7. When it will reach to 1.1.7.0 to 255, that is
Right.
last IP address. Okay. You cannot use out of it.
Okay.
Okay. That is the
Right.
meaning of it. So /24 means, so, let me come back to this page. Okay. So what is /24? Okay. So if you understand /24, so here we have, 0.000000000. Okay. So 8, then we have next 0.0000000. This is 8. Then we have 0.000000000, and then we have again 0.00000. These 8 bits, correct?
Oh.
So your 8 bits, these are, let's suppose 1, 2, 3, 4, 5, 6, 7, 8, then 9, 10, then up to 16 here, and up to 24 here, and up to 32 here, correct?
Yes.
So here, if you are using /21, okay, correct? /21. So what is the meaning of /21? /21 meaning is, like this is your 24th bit, this is 23rd, this is 22nd, and this is 21st, correct?
Yes.
So
That's
what you
correct.
are doing, you are fixing it up to 21.
1.
Okay. So that is why, the IP range I just showed you, okay, it is going from 1.1.0.0 to 1.1.7.255, correct? Why this is going to 7? Because these 3, okay, up to this fixed, correct? And you can
This
change
fix.
these
Yeah.
3 as well as you can change these 8. So if you
Page.
will change
Yes.
these 3, here it is 1, 2, and 4, correct? If you will make all of them 0, 0, 0 equals to 0, correct? And if you make all of them 1 equals to 4, 2, 1 equals to 7, correct?
7. Yeah.
So your range can, you can use these bits like 0, 0, 0. Then you can use 1, 0, 0. Okay. Then you can use like 0, 1, 0. Then you can use 1, 1, 0. Then you can use 0, 0, 1. So means equals to 0, and this equals to, because just count these 1, 2, 4. So all of them 0 means 0. If it is 1, it means equals to 1, correct?
1. Yeah.
If it is 1, it is equals to
3.
2. Yeah, here we only have,
2.
yeah, because this is
Okay.
0, this
0
is
and
0.
1. Okay.
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 2. And here we have this one and this one.
3.
So 3.
Yeah.
Okay, this is 3. And here we have this one and all these 0. So what is
4.
this? 4. If we want to make it 5, 1, 0, 1, correct? It will be your 5. And how you want to make it 6? 1, 1, 0. Okay. Equal to
Yeah.
6. And if you want to make it 7, 1, 1, 1 equals
1,
to
1, 1,
7.
1.
Okay. So this is how this range is being calculated. Okay. So you just need to focus on the slash notation. Okay. So whatever the slash notation that you have, if it is 23, it means up to 23, you will have fixed. Okay. And Okay, up to 23 you will have fixed, and you have only one bit. Okay, so one bit, either it could be 0 or it could be 1, correct?
Right. Correct. One, two,
So
three,
the
four.
IP address that you will be ranging, it will be either 110.0 or 1110. Okay.
Mm-hmm.
So this is how you can limit. It just depends how many users or hosts that you need. Okay. So with,
Right.
yeah, with this one, you can have 255. Okay. So if it is going
Mm-hmm.
to 1, it means you can have 512 users, correct? If it is going to
Yeah.
2, it means just add 255 into it. And if it is 4,
Mm-hmm.
just add another 255. Okay. So that number of IP address that you will get from this range.
Mm-hmm.
Understood?
Yes, sir.
Okay. So although like initially when I learned it, before 10 years, so that time, like here in India, we didn't have, internet that famous or available, okay, for us. So we used to calculate these things manually, okay, on the books. But now, like even it's been long, I never calculated these things. I just go there, okay, how many users I need, okay. I just go and select the notation. I just
Mm-hmm.
type the IP address. So my IP address could be let's suppose it could be 9.10.7.0. Let's suppose this is my range, and I need, around 255 users. Okay, so 255, we know it, they comes into /24, correct?
Mm-hmm.
So here, 254 users, I will get it. Okay. And I will
Right.
also get what are my usable IP. So see, my first IP will be 9.10.7.1, and my last IP will be 9.10.7.254. Let's suppose I
Mm-hmm.
need only 128. Okay, so what I'll do, I'll go with this 25. Okay, if you want
Mm-hmm.
need less users, less host, you need to increase the value. Okay, as much as closer you will go to 32, you will get lesser users. Okay, and as much as far you go down, okay, you will get more numbers. Okay, so if I go plus 25 and I'll calculate, so see, I will only get 126 IPs. Okay, usable
Mm-hmm.
IP. And if I go with the, let's suppose 28, just calculate it. See, I will only have 14 usable IP address in this range. Okay. And my slash
Right.
notation will be /28. And let's suppose, okay. And let's suppose also go up /30. I only need 2 IP address. Okay. Then go with /30. So in /30, you will only get 2 IP address, 9.10.7.1 and 9.10.7.2. Okay. You will only
Mm-hmm.
get 2 IPs. Understood?
Yes, but yes, now.
Okay. So this is how you can calculate these things. Okay. So just open, IP calculator. Okay. And then try any, IP range. Although now you understand the IP range cannot exceed, okay, our range.
Mm-hmm.
Okay. The range, that range is only, it has to be between, that it should start from 1 and it can go max to 2 to 3. Correct? Because after
Right.
that, class D is for multicast, that is reserved, and class E is for experimental purpose, that is reserved. So your IP range, okay, in the first octet, it cannot in the first, okay, this restriction is only for the first octet. Okay. So what I mean, your IP in the first octet from 1 dot, in the second octet, it can go up to 254, 254, and 254. Correct? In
Mm-hmm.
only first octet is reserved. Okay.
Mm-hmm.
So your first octet IP cannot be more than 223. Okay, it can go to 255, 255, and 255 max. But first
Mm-hmm.
octet has to be 2, 3. But if you make it 2 to 4, man, this is incorrect. Okay, because it comes to the multicast. range, that class D. Okay, understood? So just practice
Yes,
it.
sir.
Okay, go ahead to these Google, calculators. Okay, and just calculate the values. Okay, just take the IP. Okay, 1.1.7.1. How I will calculate. So what will be the usable range? So here it becomes very easy. It shows you what will be your usable range here. Okay, so network address means your first address. Oh, sorry, your network address. Okay, your assigned, okay, usable host. So these are the IP address that you can assign. Okay, and this will be your broadcast address. Okay, how many IPs or users you get? 2046. Okay,
Yeah.
now if you want to go with the less, so see here, if you go with the /13 notation, okay, means you
Mm-hmm.
will only get 2 IP addresses.
Mm-hmm.
Okay, understood?
Yes.
So just practice these, okay? Just get familiar, okay? That's
Yeah.
fine, okay?
Oh, yeah.
Whether, yeah, so like when you will, because, like you did your graduation, correct? So when you went to your college in the first year, so it's not that whatever your teacher were teaching you, you were getting everything, correct?
Mm-hmm.
You
Mm-hmm.
just went to your home, you did your research, you read the book, okay, and after that
Mm-hmm.
you ask your colleagues, your teachers again, then you understood, okay man, this is what this logic, okay, then
Yeah.
this is how we move,
Yes.
correct? So this is
All
first
right.
class, this is your first class for the IP address, okay.
Mm-hmm.
Yeah, so that is what the IP address, okay. Now, like these are the public IP addresses, okay, but we also have private IP addresses, okay. So public IP addresses means, like we took an example last week. So it's a society, okay, that have multiple multi-floor buildings, correct?
Yeah.
So they use some internal, okay, so it's one building, then okay, this particular building or society is in Texas, then in Florida they also have a society, okay, and they have, okay, so it is possible that in Florida they may use same name, okay. So let's suppose it's Mamu, okay, constructions, okay, and you have another same Mamu society, okay, and here Mamu
Mm-hmm.
society, okay, and here you have tower 1, tower 2, tower 3, okay, same here you have tower 1, tower 2, and tower 3, correct? Because anybody can use it, okay, and even not Mamu, let's suppose I have Rishi, okay, Rishi in India, I also have this society, and here I'm using tower 1, tower 2, and tower 3, and even same 101, 102, 103, okay, then here this is 201, 203, and this is 301 and 302, okay, like floor, correct?
Mm-hmm.
These same addressing scheme, anybody can use it, correct?
Mm-hmm.
So same way, like because this addressing scheme is relevant only within this premises, correct?
Mm-hmm.
And this addressing is only in this premises, and this is only in this premise. That is why it is not impacting others, correct?
That's correct.
Yeah, so the same way we have organization, okay, like Facebook, Google, they have their companies, correct? So they're
Mm-hmm.
in the internal network, they can use some IP ranges, okay, IP range, okay, those are common for everybody, okay, because they are relevant only to this premise. These are only to this premise, okay, this is only to this premise, okay. So we call such ranges or IP addresses private IP address, okay. So Internet Authority, INA, provided some private IP range, okay, those can be used by anyone, okay. And what these are, okay, one moment. Okay, so these are our private IP range. Okay, so in the class 1, the private IP, if the IP address start with 10 and /8, so this is the private range. So any organization in their, within the organization, they can use this. Okay, so Google, they can use the same 10.0.0.0/8 in their network. Facebook can also use it, okay, without any permission or without any approval. Okay, anybody can use this IP range. Okay, this is private IP range. So the same way in the society, we had tower 1, tower 2, tower 3. So even within your city, you have multiple societies. They can use the same, tower 1, tower 2, tower 3 naming convention within the society, correct? They can use the same house numbers, 101, 102, 103, 104, correct? Mamu, are you getting me? Hello, Mamu, are you there? Hello.
Yeah, I hear you.
Okay. So are
I
you
can hear
with me?
you. I'm with you. Yes.
Okay. So yeah, because the tower 1, tower 2, and even the house number in tower 1, those can be common
Those
in
can be
multiple
common in
societies.
multiple societies.
Correct?
Correct? Mm-hmm.
So same way, the INR, the Internet Authority, they provided some private ranges in every class. Okay. So in class A, class B, and class C. So 10 is from class A, correct? Because class A range
Mm-hmm.
is 0 to 127, correct?
120. Yeah.
So in the class A, they provided a complete range for the private. Like any organization, they are free to use within the organization, but not outside. Okay. Then in the
Right.
class B, because class B range is 128 to
28 to 191.
191. Okay, so that comes into class B. Okay, so in the class B, you can use this range. This is the private range that you can use in your organization. Okay, you do not need any approval or you do not need to pay any money for that.
Right.
Okay, and the third one, that is class
That's
C.
a class C.
Okay,
Yeah.
192 and 168. So that
Mm-hmm.
192 and 168, these are fixed. Okay, and after that, these are okay. These can be 0, 1, 2, 3, 4, up to 255. And this can also be 1, 2, okay, for every IP. Okay, so these are
Yeah.
three. These three ranges are the private IP ranges. So any organization can use these IP addresses in their internal network.
Right.
Okay, so
Right.
just remember these things. Okay, what are the private IP range that we have? Okay, apart from these range, all IPs are public. You have to pay for that to get public IP addresses. Okay, so they have a procedure.
Mm-hmm.
First you need to go, to request for the IP ranges. Then you have to provide how many public IP address that you need. Okay, so same way you need to
Right.
provide your requirement and they will give you the available IP addresses. Okay, it's not that you will get your choice IP address. Okay, so whatever IP addresses are available, they will provide from that. Okay.
Yes.
Okay. Now, like these are the things, okay? Like because IP address, you just so same way, like in the human, we human beings, we use cities, okay? City like Florida, Texas, and New York, because these are very easy to remember, okay, to recall, okay? In computer networking things, we use IP address, okay? Instead of a place name, we use the IP address, correct? Yeah.
Yes.
And also, even now you can ask me, hey, Rishi, you are saying in the internet thing, we use IP address. But whenever you access Google, Facebook, we use the names, correct?
Yeah, we use the name. Yes.
Yeah. So
That
why
is,
we,
I can
because,
correctly say,
Mhm.
so I can correctly say IP address is a connecting link,
Yes.
routers connecting link.
Yeah. So IP address is the one that connects devices on the network. Okay. But
Yes.
why we have facebook.com? So facebook.com, because who are using these things? Humans, and humans are very poor to, remember numbers. They can remember a string or any place name or any names, but
Mm-hmm.
they are very, bad to remember numbers. Okay. That long numbers. Correct.
Right.
So same way, they did one thing, they mapped, like suppose facebook.com, okay? So if you will access facebook.com, so here you see facebook.com. One moment, come on, come on, come on. Okay, so here you see facebook.com, but in background, facebook.com has an IP address. How you can check it? So go to your, system here and open command prompt. Okay, CMD. Just type
Mm-hmm.
CMD. Open CMD
CMB.
and type
Mm-hmm.
NSLOOKUP. NS
Look
lookup.
up.
Okay, and then type
Facebook.
facebook.com. See, this is the IP address that Facebook has. So when I'm accessing facebook.com, my system is changing that facebook.com to this IP address. Okay. And then the packets are going to the Facebook server. Okay.
Mm-hmm.
Now see why we are using facebook.com, because can you remember this?
Yes. It's a private IP.
Yeah. So this is the IP range. Okay. So can you remember, like suppose today you remember it. Okay. This is the IP address of Facebook. But let's suppose
Facebook. Yeah.
after 1 month, I'll ask you, hey, Mamu, what is the IP address of Facebook? Can you tell me?
Oh, yes, I can.
Okay. So,
Yeah. So
let's.
I go to when I open I type Facebook .com,
Mhm,
then I go to my command over
mhm,
here.
mhm.
Hmm?
Yeah.
Uh, then I type NS
Facebook.com.
lookup.
Yeah.
NS lookup.
Yes.
Yes. Then
And then
I
you will
type
resolve it. Okay, it
Facebook.com.
will tell you what
Mm.
is the IP address. Okay, but
Yes.
normally, let's suppose we don't have facebook.com. Okay, if Facebook company says, hey, if you want to access my, my particular, Facebook site, so you have to
Mm,
type the IP address instead of facebook.com, then it will be
mhm.
very difficult for the users to remember these numbers. Correct?
That's correct.
Yeah. So that is why they came up with this FQDN, the fully qualified name. So they will be very easy for the human beings to remember. Google.com,
Mm.
Facebook, or so. Now, if you want to check the IP address for Google, google.com, type. See,
.com.
this is the IP address of Google.
Yeah.
Okay. So what thing? So our DNS server, domain name system, okay, they keeps track of all the FQDN with the IP address. What is the IP address? Okay, so if you are opening, or suppose you are setting up a site, okay, so mamubusiness.com something, okay,
Mm.
so if you are hosting your website over there, so now you need to request a public IP address, okay, and you need to
Right.
register mamubusiness.com and that IP address. So if anybody on the internet, if they will type mamubusiness.com, the
Mm-hmm.
systems will automatically resolve the IP address and will direct to your server.
Server, yes.
Okay. So that is the work that DNS does. DNS resolve the fully qualified names to the IP address. Okay.
That's correct.
Yeah, so that is the work of DNS. Why we did it? Just for the, like easiness for the human beings, because they are good at
Mm-hmm.
remembering the strings. So now you are good. So far, so good. What is the private IP range that we have? Okay. So please make a
Yeah, we
note
have,
of these things.
yeah,
Okay. And
we have a three private IP address range.
yeah. IP
The
address range.
class A, B, and C.
Yeah, so we have three, that is 10.02. This,
Mm-hmm.
okay. So if we go with the slash, or if you just go with this images, and if you will type, okay, open this. Let me just open this one. Things are available on the internet, okay. So whatever comes to your mind, just search, okay.
I just search for it, yeah.
Yeah, search for it. Things are available. Man, when I learned these things, okay, I did not have any internet connection, okay. I used to get around, I would say in $4, I used to get only 128 MB for 1 month.
Wow.
In $4, 128 MB for 1 month, okay.
For one more. And look at us today now.
Yeah, it was that expensive. Okay, so now it is
Now
very
you get
cheaper.
it
Okay,
free.
now I get it in the around same money. I got unlimited. Okay, for a month.
Unlimited,
Okay,
yes.
unlimited
Yes.
for a month.
Exactly.
Okay, so that much expensive it was. Okay, so
Exactly.
used to do these things manually, but you just need to understand it and then use it. Okay, so here you have
Mm-hmm.
these private IP ranges. Okay. Oh, one moment. Okay, if we go with the slash notation, so private, if we go with the slash notation, 10.0.0.0/8 is the private range for the class A. 172.16.00 up to 172.31.255. Okay, that's /12. This is the range of class B private. Okay, and class C is 192.168/16. Okay, understood? Mamu?
Nice.
Okay, great. Now, the next thing, I believe, okay, we didn't have this session with you. So now you need to check the IP headers. So have you ever had any chance to learn networking, or you had any, subject in your graduation?
Yeah, that was many years ago, but yeah.
Okay. So if you had, then we have the IP header. Okay. So the packet that
Mm-hmm.
we are forwarding. So the same thing, if you want to forward something, okay, suppose you want to send a gift to one of your family member or your colleague. Okay. So what you will do? So let's suppose it's an iPhone. Okay. So it's an
Mm.
iPhone. So what you
Yeah.
will do? First, you will buy it. Okay. Then you
Mm-hmm.
will put it to a box. Correct.
Mm-hmm.
And then you will put
Address
your address, okay, and then you will courier it, okay. So whenever your
box.
friend or colleague will receive it, what they will do, they will open this first
Mm-hmm.
box, okay, then they will open the second box, and then they will get the iPhone, okay. So same way,
iPhone,
if
yeah.
we have a packet and we want to forward that packet to one place to another place, so what we need to do, we need to wrap it, correct, into a box,
Mm.
and we need to write the addresses. So in the networking, what is the addressing scheme that we use? IP address, correct?
Mm-hmm.
So you need to write the IP address. So source address, whatever will be your public IP address, okay? 1.1.1.1, and let's suppose destination is 7.7.7.7. Okay. So now your routers, they have the routing table, and on behalf of your destination IP, they will forward the packet from one router to another router, and then it will reach to the destination. Correct?
Mm.
So that box, okay, that because in the physical form we use some cardboards box, and then we write the address, correct, but here in the networking we need some headers, okay. So we have the IP header, okay. So that IP header is contains the data that you want to send from one place to another place, okay. So if we open this, okay, so this is the IP header that we have. Okay. So that version field, what it says, version means it is an IPv4 or IPv6, correct? So what is
Uh-huh.
IPv6? So IPv6 is the next version of IP ranges. Okay. Like because in the uh, like in the IPv4, we have the limited number of IP addresses, correct? But now these days,
Uh-huh.
if you see, like we have mobile phone, we have home devices, we have, even you can set up your home automatic. Okay, even your cars are connected to the internet, they also need the IP address, correct? So the
That's
requirement
correct.
for the IP address is getting increased, so like drastically. So that is why they need a next version. Okay, because what if that complete IPv4 addresses are assigned to all the devices? So after that, what you will do? Okay, so to resolve this issue, they are coming up with the next version, that is IP version 6. Okay, so that will be having, so many IPs. Okay, so IPv4, it has IP address up to 2 to power 32. Okay, and
Uh-huh.
IPv6, it has an IP address of 2 to power 128. See how many IP addresses can have in IPv6 range.
Uh-huh.
Okay. So like in future, like to resolve this, they are coming up with this. Okay. Although let me give you, although like the IPv6 addresses are very difficult to remember. Let me show you. See, this is the IPv6 address.
Okay.
See, so this is your IPv4, this is your IPv6. Okay, there are 8 octets that we have in IPv6. Although like these things will be automatic, okay, you do not need to worry about these things. Okay, so
Uh-huh.
these days we have our DHCP servers, and even the IPv6, it has some other features as well. Okay, so where automatically they will be, configured on the devices, they would not require any manual intervention. Okay, so although these days
Uh-huh.
I have, more than 10 years of experience, and I have never seen any organization they are using IPv6 addresses. Okay.
Okay. Yeah.
So it's not being widely used in the organizations. Okay, now we are coming back to our IP headers. Okay, so this is our IP header, IPv4, where it is. Yeah, here it. So the first field that we have, it tells us that what is our version. Is it an IPv4 or IPv6? Correct?
Uh-huh.
IPv, let's suppose here we have IPv4. Now IHL. So this is internet header length. Okay, the header length. Because here you see whatever data that you want to send from your PC to any other destination. So we are putting that data here. Correct?
Right.
So now this is our data part. But this is our header, okay, where you are mentioning what is the length. Okay, so even if you remember, if you have sent a courier to anywhere, so they weight it. Okay, so as per the weight they will charge you, correct? Then you have to put
All
your
right.
like uh, your source address, your from address, okay, your to address where you want to forward. Do you want to give it priority? Because sometimes you, for your data, whatever the courier that you are sending, it is not, the time is not the constraint. Okay, if it is reaching within a week, that's fine. But if you want to send something that has to reach within 48 hours or within 24 hours, so you have to pay extra for that, correct?
That's correct.
Yeah, so same way, In the physical thing, we go to courier companies and they do all these things for us. But for the internet things, these things should happen automatically, correct? So that is
That's
why
correct.
we need these headers, okay? Where our systems will be defining these things. So IHL, it will be defining what will be the header length, okay? Because this is our
Mhm,
header and this is our data. So we have two parts. One is header part and one is data part, correct?
mhm,
Data actually
mhm.
contains what exactly we want to send, and header part contains what is your source IP, what is your destination IP, okay? Do you want to give it some priority, okay? What is the length of the complete box? The same way, what is the weight of your box that you are forwarding? So all these things we are putting in the header part, okay?
Say that, yeah.
Yeah. So the header part for IPv4, it's a 32-bit, okay? So 32-bit, this one row equals to 32-bit. Okay. Then second
Okay.
row, this is also 32-bit. And you know, 8 bits equals to 1 byte, correct?
1 byte, yeah.
If we have 32-bit equals to 4 byte, correct?
1 byte, yes.
So this one column is equals to 32-bit, or we
Mm-hmm.
can say it 4 bytes, correct?
That's correct.
Then this one is also 4 byte. This one is also 4
Four
byte.
bytes.
This one is also 4 byte. This one is also 4 byte. So
Mm-hmm.
these 5 fields that we have, these are mandatory. You cannot skip any of the values. Okay.
Okay.
These are mandatory. So if we come to define the header length, what will be our minimum header length? 4 byte, 4 byte, 4 byte, 4 byte,
Four
4.
bytes, 4 byte.
20.
Four.
Correct?
That's
4 into 5.
correct.
So your header length cannot be less than 20.
Mm-hmm.
Okay. And it can go maximum up to these options. So these are optional fields that we have. Okay. And the optional
Mm-hmm.
field value is 40 bytes. Okay. So
Yeah.
your header length minimum value has to be 20 and maximum it can go up to 60. Correct? 20 this
Uh-huh.
and 40 if you are using, because these are optional.
Optionals,
It's
yeah.
not mandatory that you use it. If you are not using it, your value will be 20. If you are using it, it will be, 30, 40, 50, 60. Okay.
Right.
So this is how your header length. Now, this is type of service. So type of service means what priority you want to give to this particular packet or data. So same
Mm-hmm.
way, if you have to send something immediately, so you will go with the speed post. Okay. And if you want to go with delay, then you will go with your normal post. Okay. That it will take 1 week. So if you want,
Mm-hmm.
data is very important and you have to send it, with high priority. Okay. So what will happen? We will be using the QoS. Okay. Type of service. This field will be used for QoS, quality of service. Okay. What is the quality of service that you want to give? So if you want to give it high priority, then you have to use the high priority field, QoS here. Okay.
Mm-hmm.
Now this is total length. So total length means total length of this particular packet. So it will be header length plus your data. Correct?
Yeah.
Header length IHL plus your data. If we add both of them, it will be your total length. Okay. Let's suppose
Talent, yeah.
the total length of this field is, it is 1000. Okay. And if someone says you, hey, like Mamu, please tell me what is the data length of this particular packet. So what you will do, because what is total length? IHL header length plus data.
What's
Correct?
that, yeah?
It is
Mm-hmm.
1000. So now header length, we know what is our header length. Correct?
Yeah.
So what you
The
will
header.
do, let's suppose it is 20. So what you will do, you will subtract 20 and then it will be 980. So it means
Mm-hmm.
980 is your data size and 20 is your header size. Understood?
Okay.
So this
Yeah.
is what helps the devices to identify what is because on the internet, our data goes into 0 and 1 format, okay, in the binary format, correct?
Mm-hmm.
Now, it will be 0 1 0 1 1 1 1 0 1 1 0 0. This way it reaches to the end system. Okay, then how your endpoint system will identify what is the value of this? Okay, so this is how they calculate. Okay, 980 bytes. Okay, it means they will calculate the 980 byte last as in data part for data processing, and this part will be discarded at when it will reach. Because same way, if you are forwarding the courier and you have an iPhone in between, whenever your colleague or your friend will receive it, what they will do? They will unwrap it and they will throw it. Correct? The outer box.
Right.
What is important? This. Now,
Yeah.
same way, when your packet will reach to the destination, they will discard your header, because your header's responsibility was only just to destine it, okay, to send it from one place to another place. Now your packet is reached. Now you do not no more require the header. Correct?
Uh-huh.
Yeah. So same way, like when your packet will reach, they will calculate from total length. They will subtract this. They will remove those bytes, and these things will be relevant, and they will forward it processing for the application.
Right.
Okay. So this is how that these values are relevant. Now, the next field is identification. So this identification field is used, when you are fragmenting the packet. Okay. So let's suppose you have, so it's a, wood. Okay. And it's, 20 feet long. Okay. 20 feet long. And but you have boxes of 2 feet box. Okay. And you want to send this particular wood to one place to another place in any condition, that's fine. Okay, so what you will
Uh-huh.
do, you will chop it into 2 to fit size. Okay, and you will make 10 pieces. Correct?
Yes.
And you will put in one box, you will label it one. Then you will take another 2 feet box and you will put this here, then label number 2, then label number 3. Correct? So then you will send them. Okay, you will courier them. When they will receive at the destination, what they will do, according to the numbers, they will receive it one, they will use some glue and they will stick all of them. Okay, and they will again make it same way. Correct? 1 2 3 4 5 6 7 8 9. Understood? But here, identification. Okay, so let's suppose you have two woods. Okay, so what is the wood that is famous at your place? The trees, those are famous. Mamu,
Uh-huh.
which tree is
Yeah.
famous that you use to build your house or something?
Wood. You mean the woods?
Yeah, woods.
What's your question again?
Okay, so my question is, okay, so what I'm trying to say, so when you are forwarding, these, when you are chopping these okay, these woods, okay, into 10 pieces, 2 feet, 10 pieces,
Pieces.
okay,
Yes.
you are numbering it. Okay, okay.
Yeah.
So those identification field, it contains those values. Okay, so
Those
this is,
values,
let's
yes.
suppose, like this is, uh like like what I would say, it's an, sandalwood. Okay, sandalwood. This is the, wood, tree. Okay, that we have. And this is first piece, this is second, this is third, this is fourth, this is fifth, this is sixth. Okay, so that identification will contain this sandalwood, and that fragmentation offset, okay, it will contain, this is the first, this is the second, this is third, this is fourth, this is fifth. Correct? So there are multiple fields that we have. Okay, so although you do not need to worry about these things, we are not going to use. Okay, you are not going to use these values anywhere. But why I'm telling you, so that at least you have an idea about it. Okay.
Right. Right.
Okay, just have an idea for you. Although I can skip these things and I can directly go to the firewall teaching to you. Okay, but no, either you don't understand, even you just understand 10%, that, you know, that really makes sense. Okay. Because if at any point of time, if we are discussing anything relevant to it, you will have an idea, oh man, that is what it is. Okay.
Right.
Yeah.
Right.
So that is why I'm discussing. Otherwise, like if you want, I can skip. Okay. But I want you to know. Okay.
Yes. Yes.
Yeah. Then the next thing is the TTL. Okay. Time to live.
Okay.
So what is TTL? Let's suppose, even you sent a courier, okay, and you don't have, like wherever you sent the person, he shifted from this place to another place. Okay, no one is living here. Okay, no one is living. But in physical thing, what will happen? They will return the box to you because you mentioned your to address, correct?
Mhm.
But in networking field, we do not have any way that if the destination is not found, then your packet will come back to your PC or your phone.
Right.
It will not come.
Right.
What will happen? It will keep wandering from one router to another, one router to another, and forever. It will be forever, passing from one device to another device. And it
Uh-huh.
will be a mess. You see, if we have, high number of packets, those are traveling without the destination because we don't find any destination. So they are going from one device to another device, correct? Unnecessarily. So
Uh-huh.
to resolve this issue, they came up with this TTL value. Okay. So the maximum value can be up to 25, but it also depends on the operating system. So most of the operating system, they keep it 128. So 128 means this device can go up to 128 routers. Okay.
Right.
So as soon when it reaches to first, that value decreases to 127, then 126, then 125. And when this value reaches to zero, the device, wherever it becomes zero, it drops it. Okay, the packet will be dropped. Okay,
Uh-huh.
so the packet will not travel unnecessarily on the network for the infinite time. Okay,
Right.
yeah, so that is the meaning of this. Okay, then we have protocol field. So what is
Uh-huh.
protocol field? So protocol means it tells what data I am keeping. Okay,
Uh-huh.
what data I am keeping. Okay, is it a TCP data or UDP data? Okay, so I'll tell you about TCP and UDP as well. Okay, so don't worry about
Okay.
it. Then
Uh,
we have header checksum. So what header checksum is? So let's suppose, okay, so when you are boxing something, so what you do? You tape it well, correct?
uh-huh.
So, and you also advise to the receiver, and even let's suppose you ordered something from Amazon or from online. So when you
Uh,
receive it from the courier guy, what you check, the first thing you check, it is not, like tampered, correct?
yes. Yeah. Make sure it's still sealed and
Yes.
protected.
Yes,
Yeah.
yes, it is not tampered. So the same thing is doing that header checksum. Okay. So when the sender is sending the packet, it calculates the a checksum value, or like they follow some mathematical algorithm and they put that value here. Okay.
Uh-huh.
And when the receiver receives it, receiver again calculate the same mathematical calculation, and they matches the value with this. If it matches,
Check something.
it
Yeah.
means it is intact. If it doesn't matches, it means something changed. Okay, any of the values are changed here. That's why it is not matching. Okay,
Uh-huh.
so the device
Right.
will drop it. So same way, if it is tampered somewhere, you will deny to accept it and you will return it. So same way,
Uh-huh.
if the checksum value will not match, the packet will be dropped. Okay.
Yeah.
Now, the second thing is source IP address. So source is your from address when you send any courier or something. So here in the networking, we use source IP address, and destination is destination IP address that we are forwarding. Correct? And
Yes.
here we have our data, whatever data that we are forwarding. So this is the IP address. Does it really make sense, or are you able to relate these things with the
Yeah,
real
it's
world?
with the physical world. Yes.
Oh man, great. Now, let me also tell you one more thing, that is OS. Are you aware of OSI model?
No.
Okay.
OS.
OSI layers.
Again.
No, give me one moment.
OSI.
Yeah, give me one moment.
Yeah.
Okay. Yeah. So OSI layers. So these are the 7 layers, okay, that we have on the internet. Okay. So
Mm-hmm.
why we have these layers? Okay. Because on the networking, or even let me just give you another example. So let's suppose you are living here. Okay. So this is your house. Okay. And here, like we have here we have water, and here on island, it's your friend house. Okay. Let's suppose this is my house. Okay. This is Rishi's house on an island that is surrounded by water. Correct? You have a car. I have a boat. Correct? And that is, let's suppose it is 10 miles away. Okay. That water, that it starts after 10 mile, and then you have 5 mile. My place is in the water after 5 miles. Okay, that island. Correct? So now total is 15 miles. So now if you want to visit to my home by your car, can you come to my home by your car here?
Yeah.
Can you come? Can you drive your car in water?
No, cannot.
So you can only come up to here, correct? And even
Yes.
if I want to visit to your house, because I have a boat, so I
You take
can,
your boats
yeah, my boat can only come up to here, correct?
to the land. Yeah.
I cannot, ride it on the road, correct?
Mm-hmm.
So we do not have a standard way or a standard vehicle that we can reach to each other, correct?
Right.
So same way, like we have, devices, we have IBM servers, correct? We have Lenovo, okay? We have, Apple devices, correct?
Mm-hmm.
We have Samsung, okay. So if all of them, they will be using their own network architecture or addressing scheme, okay, or standards. So
Right.
only IBM to IBM can communicate, Lenovo to Lenovo, Apple to Apple, and Samsung to Samsung. Like they cannot
Mm-hmm.
travel, transfer devices or packets to each other, correct? Because they are using
Right.
their own models, okay. So own vehicles. So same way you have car and I have bought. So like we do not have any similarity. So same way
Yeah.
they cannot send the packet to each other because they are using their own mode of transferring or just representing the data. Correct?
Mm-hmm.
So to resolve this issue, the Internet Authority, what they did, they came up with a standard rule. Okay, that hey, even though you might have different features in your application in your servers, but to communicate to each other you have to follow a standard way. Okay, then only you can communicate to each other. Okay, your devices can communicate to each other, correct?
Right.
So is the Internet Authority that governs all of these things. Okay, and they came up with this model, 7 layer model. Okay.
Oh, right.
So we have 7 layers. The top one layer, they call it application layer. Okay. So when you open your browser, okay, your browser, it's an application. Okay.
Application.
When you open WhatsApp, when you open, Facebook application on your phone. So these are applications. Okay. Now the presentation. Okay. So there are multiple, like if you see JPEG for the image, for video, we have MP4. Okay. And for, audio, we have MP3. Okay. The presentation of the data that we present, correct?
Mhm.
Then session. So that session is from application to application. Okay. So, you see whenever you access WhatsApp or something, so, your WhatsApp to another WhatsApp, if you are using both, so it shows you online and these things. Okay. So there is a kind of communication that happens. Also, it's a session that is being created from WhatsApp to WhatsApp. Okay.
Yeah.
And even you are making phone calls. Okay. So like it is creating a session between your application to application. Now we have transport. Okay. Layer, the next layer, that is transport layer. Okay. Now, if we take an example, what is transport layer? Okay. So same way, if we understand it, let's come here. Here, this is your, home. Okay. So you have, and even this is my home. Okay. And now, we both live, we are connected with the roads. Okay. That's fine. So here you have room number 1, room number 2, room number 3, room number 4. Correct? 1, 2, 3, 4. Then you have 5. Then you have, room number 6. So same way, I have room number 1, room number 2, 3, 4, 5, 6, 7, 8. Correct? Now you live in number 2. Okay? Here Mamu lives. And I live in room number 7. Correct? Rishi. So if Rishi
Right.
is sending you something, okay, what I'll do, I will use only this address. Okay. Let's suppose Florida, and the society is XYZ society. Okay. But I did not mention the room number or the flat number. So
Mhm.
what will happen? The packet will reach up to this, but here there are 6 rooms whom to deliver. Correct? No names
Right.
mentioned. So the same way we use, if because even on the system, okay, the system that we have, okay, even on your phone, you have WhatsApp, okay, you have Facebook, you have YouTube, okay, and you have other applications as well. Correct?
Right.
So if you have so many applications, okay, so how you will identify like your packet will be delivered to which particular application? Correct? So
Yeah. Correct.
to resolve this, they are using that transport layer. Okay.
Yes.
So your transport layer will define, okay, even when the packet will be delivered to the destination, okay, to your device, but to which application your packet will go.
Fast.
Okay. So that
Right.
work is being done by the application, sorry, transport layer. Okay. That transport layer. So it creates
Mm.
an end-to-end communication on the system. Like from room number 2, it sent to, from room number 7, from Rishi to, it sent to room number 2 to Mamu. Okay. So the same way, like whichever application that you install, they uses some port numbers. Okay. So it tells the packet is reached to your particular phone or your device, but on which application this traffic is supposed to go. Okay. So that is being taken care by the transport layer. Okay. Now network layer, you are already aware. We use IP addresses here. Okay. So your source IP to destination IP. So your from address, your to address, that takes your packet from one router to another router, and then it destine your packet. Correct?
Right.
Then we have data link layer and physical layer. So those are the, you see the physical boxes, okay, that takes from one place to, so all these like the wires, okay, the wireless medium you are using, radio, or like wireless medium or wired medium, or you are using fiber. So these things are taken care by the data link and physical layers. Okay, your physical
Mm-hmm.
transmission of the data. Now, the 7-layer model was the initial back in the days, okay, when they came up with this. But these days we use TCP/IP model. Okay, so in TCP/IP model, we only have 4 layers. Okay, so now if you will try to understand this, they did nothing. Okay, see, this is the difference between TCP/IP and your OSI. These are OSI and this is TCP/IP. What they did, they merged all these 3 layers
Three.
into
Okay.
one. Okay, they made it application because these things are related to application. Okay, so what they did, they merged and they made it one. Correct?
Right.
Transport, no changes. Network, no changes. And the last two, they were just for the physical medium. Okay, they merged it
Okay.
into one. Okay,
Mm.
so now out of 7, they made it 4. Okay, and that's the model that is being used these days. Okay,
Okay.
so
The
about
TCP/IP model is the model we use presently.
yes, TCP/IP model we use presently. Okay,
Okay.
so application like your browser, okay, your WhatsApp, your Facebook application. So these they works at the application layer. Okay, and here we have TCP and UDP protocols. At transport layer, we have two protocols, TCP and UDP. Okay, so what is TCP and what is UDP? So let's suppose you want to forward something. Okay, you have a letter. Okay, and that is not very important. So what you will do, have you seen the letter box in your city or nearby to your home whenever you want to post something? So if it
Yeah.
is not something important, you just put that letter into this box. Okay, but they don't give
Yes.
you any guarantee that it will reach or not. Correct?
All right.
So if you are lucky enough, it will be delivered. If you are not, then it won't be. So there is nobody takes any responsibility and nobody gives you guarantee. But if you do speed post, okay, or a courier, so they gives you a reliability that your packet will be delivered to the destination, and even you can track it as well. Correct?
All right.
Yeah. So UDP means not reliable. Just put
That's
the
right.
packet into the box, okay, and there is
Uh-huh.
no guarantee it will reach or not. But if you are using TCP, it is reliable. It gives you guarantee that whatever packet byte to byte that you are sending, it will be delivered. I guarantee you. If something is getting drop in between, I will come to you. I will take the that same packet again and I will deliver it again. Okay.
Right.
So that is TCP. Now you understood what is UDP and what is TCP. I cannot explain you that easy. Easier
Mm-hmm.
than this. Okay. So that is UDP and TCP protocol. Those works at a transport layer. At internet layer, IP address. Okay. Our IP works. And here we use Ethernet. Okay. So these days
Okay.
we use Ethernet. Okay. So whenever you have even to your home, you would be having LAN cable that you connect to your PC to the internet. Okay, or to the wireless medium. So they use the Ethernet protocol. Okay,
Okay.
to forward that packet. Okay, that works at at physical layer. Okay, so when you are using fiber or something, actually it transfer your packets physically. Okay, from one place to another place. Okay, it is a carrier.
Okay.
Okay, so now you understood the 4 layers.
Yes.
Top one is the
Yes.
application, then transport layer, then internet layer, and then network access layer.
Yeah. The internet.
Yes, yes.
The
Great.
the okay. The internet layer is what's the idea?
Sorry?
Okay. The application layer. I know the network access layer is for the internet. Because I'm
Yeah.
trying to make a note. Yeah. The
Okay.
application layer is what?
So
What do you connect
application
it?
layer is where your applications works. So browser is an application on your
Okay,
laptop.
like browser. Yes,
Yes.
yes, like browser.
So browser is an application. Okay. So browser works at application layer. Okay. At transport layer, we have two protocols like TCP and UDP.
TCP.
Okay.
Yes, and UDP. Yeah.
And here we have IP. Okay. And
Okay.
also
Yes.
if you just
Yes.
want
You
to
have
do
the IP.
ICMP, okay, these. Okay. Although just check with IP address. Okay. The IP protocol that we use at network layer. And at
Yeah.
network access layer, we use Ethernet.
Internet. Yes. That's
Okay.
it.
Yeah.
Yeah.
So these are the four layers that we have. Okay.
Congress.
So
Yeah.
now,
For the TCP IP model.
yes, this is TCP IP model. Okay. So just make a note and then go to the Google and, search these things. So you get familiar with this. Okay. Now,
Yes.
okay. So, like we are done with the today's session. Okay. I just don't want to overburden you. Okay. So are you finding it interesting or like it's boring or,
Very interesting. Very, very interesting.
oh man,
You
great.
know, it's so easy for me because the way kind of compare it, to
Mhm.
the physical environment.
Yeah, yeah, that's
Yes.
that's what I believe in. This is how I understand, this networking. It becomes
Yes.
very easy when you relate things with the real world. Okay. But
It become very, very entertaining and interesting.
yes, and even when you relate things, you will never forget these things. Okay.
Forget it. That's correct.
Okay.
Yes.
So we are done with this. Okay. So on our next session, what I
Mhm.
want you just go to the Google or YouTube, just learn about this. Okay. What is IP address? What is subnetting? Might be you will learn something new. Okay. And you will be able to relate things. Okay.
Okay.
Now, just also, I want you to Google what is TCP IP model, what is the application layer, transport layer. So you just go and read some theories. Okay. Although like they
Okay.
will go over your head, you will say, "Hey, man, when Rishi was teaching, like they seems to be very simple. Now, what wordings that they are using?" Okay. So I
Hmm.
want you to go and even if you are getting 10% from that reading,
Yes.
that's more than enough.
Hmm.
Okay.
Right.
So I want you to do that.
Right.
And also like from next okay, so tomorrow we will not be connecting. Okay, I want you to enjoy. Okay. And it's
Okay.
the
Oh, I
31st.
relax tomorrow, right?
Yeah, so tomorrow you can go wherever you want, you can enjoy with your family, with your
Okay.
colleagues. Okay. So
Okay. Yeah.
okay. So next
Yeah, that's
Saturday we will
nice.
be connecting again, and then I'll tell you what is TCP and what is UDP. Okay, some basic things about TCP. Okay, and these things,
That's,
and after
yeah.
that we will gradually move to our firewall stuff. Okay, first I'll explain you firewall theories. Okay, some
Right.
architecture of Palo Alto, why it is very famous among other firewalls, why it is so expensive, what are the features. Then gradually I'll show you how firewall it looks like. Then we will be configuring the features and go on with the practical labs as well.
That's right.
Okay.
Yeah, right. Right. We are
Okay.
getting there.
Okay, so just don't worry. So like we'll be learning a lot.
Okay. Thank you so much. Thank you so much.
Yeah,
Thank
thank
you
you.
so much, Rishi.
Thank you, really appreciate your help and your time.